Hello students, welcome to Competitive Exam Library YouTube channel. Today we are going to see problem on analogous systems by considering translational mechanical systems. So translational mechanical systems, by considering this we are going to do force voltage analogy, force current analogy. So let us start with force voltage analogy. So for this problem, you know how to draw this node based diagram. You can see from the previous videos. So how to draw this node based diagram. So here you have to identify first how many displacements are there. Here you are having one displacement. For that displacement I have connected all the elements, force, mass, spring and B constant, that is frictional constant B, I have connected like this. Now we have to write the force voltage analogies for this problem. So before going to that, what you have to do, you have to write the translational, that is force balance equation for the given system. Let us write force balance equation. So F of t can be is equals to Fm plus Fk plus Fv, that is the force balance equation. So F of t can be written as m into d square x by dt square plus k into x plus b into dx by dt. So now you have to replace this translational system elements with the force voltage analogy. So now we can replace, the force can be replaced with V of t and mass can be replaced with inductor. Next, B frictional coefficient can be replaced with resistance and K can be replaced with inverse of capacitance and displacement X can be replaced with charge Q. So now you are going to replace this. F of t can be replaced with V of t, then mass can be replaced with inductor, then charge, that is displacement, can be replaced with charge d square x by dt square. Next, k can be replaced with 1 by c. Next, q, that is x, can be replaced with q, that can be replaced, b can be replaced with resistance, and this can be replaced with dq by dt. Here one thing you can note down, here current we are already know it is the rate of change of charge. I can be replaced as dq by dt. So whenever you take differentiation on both sides, you are going to get d square q by dt square. Next, q can be written as integral of I dt. So you can replace these equations in the above equation. So we can write that as V of t is equals to L into di by dt plus B can be written as, that is R into I, plus K can be written as 1 by C integral of I dt. So just I have replaced in place of Q, in place of, I will show what I have replaced. In place of Q I have replaced this equation. In place of dq by dt I have replaced I. In place of d square x by dt square I have replaced di by dt. So now you got the equation. If you observe all this, there is a common current is flowing in all the elements. So we can write all the elements are to be connected in series. So let us connect a voltage source is present here. After that a resistance will be there. After that you are having one inductor is connected. After that there is a capacitor is connected like this. So why? Because we are connecting in series, because all the current flowing in all the elements, if you observe the equation, the same. That's why we are represented like this, R, L, and we can replace that as, we can replace this equation with 1 by C. So what is the current flowing? Here you are applying some voltage V of t plus of minus, and the current flowing here you can take it as I of t. This is the force voltage analogy. Now let us write the second one also, force current analogy. So how to draw for the same problem force current analogy? There is one simple key point is also there while you are dealing with force current analogy. What are the elements are there? You have to connect all the elements in parallel. That point also you can remember. How you are getting, you can justify here. So let us write force current analogy. So if you write force current analogy, the replacements will be f of t can be replaced with I of t, then mass can be replaced with capacitor, then B can be replaced with inverse of resistance, then K can be replaced with 1 by L, then here that is x can be replaced with V. So x can be replaced with the V here. Now let us write the equations. Let us substitute for the in this equation. So you have to substitute in this equation. So we can write I of t is equals to m into d square V by dt square, that is here m can be replaced with the capacitor. So m can be replaced with the capacitor. Here we can replace with the capacitor. Now we can replace here a small mistake. Displacement x can be replaced with flux phi. So here now you can replace this capacitor can be replaced with m, then d square phi by dt square plus k can be replaced with inverse of inductance. So x can be replaced with phi. Next plus b can be 1 by r, dx by dt can be written as d phi by dt. So now let us see all the elements. So if you observe here from the Faraday's laws, we know that V is equals to d phi by dt. So dV by dt will becomes d square phi by dt square. Next, so phi value will become integral of V dt. So now you can replace these elements here. Let us write that equation. M can be replaced with the capacitor. Once again, M can be replaced with the capacitor. dV by dt we can write plus 1 by L integral V dt plus 1 by R into V. So we can replace, these are all the elements. If you observe all the elements, voltage will be same. So voltage will be same in all the elements. So you have to draw all the elements for the in parallel for the force current analogy. So now we are drawing the force current analogy diagram. So here force current analogy diagram, if you draw all the elements, so first you will have one current source, then you will have one resistor is connected, then you will have one inductor is connected, then you will have a capacitor is connected for this. So what you are going to get here, current will be connected here, that is I of t, then R, that is 1 by R we have connected, then you have inductor and the capacitor. So this is the force current analogy, and voltage across all the elements will be same. So like this you can observe, if you observe this force current analogy and force voltage analogy, there is one keynote you can observe. Whatever the you have connected in force voltage analogy, series elements which are connected in force voltage analogy, that to be connected in parallel, when force current analogy. So force, so you have to connect in parallel force current analogy. So when you are connecting force, when you are answering the force current analogy. So that's all in this video. If you like this video, please like, share and subscribe the channel. So if you have any query, please make comment in the comment box. I can reply. Thank you very much.